Quadratic inequalities. Solving methods for quadratic inequalities. Number one, we can use graphical method or we can use algebraic method, namely number line method or table of signs. For graphical method, step 1 will be factorize the equation to get the critical points. These are values of x where the graph cuts the x-axis. For example, solve x squared minus 5x is greater than or equal to negative 6. By moving negative 6 over to the left hand side, it is in the general form. Let x squared minus 5x plus 6 equals to 0. We factorize them, and then x equals to 2 or x equals to 3 are the two critical numbers. Then step 2, the graph is sketched. Since the coefficient of x squared is positive 1, this quadratic function has a minimum point. It cuts the x-axis at x equals to 2 or x equals to 3. In solving x squared minus 5x plus 6 greater than 0, we can solve it part by part. We notice that there are two parts of the graph which is above the x-axis, and then there's one part which is below the x-axis. The graph which is above the x-axis represents y greater than 0, and the graph below the x-axis represents y less than 0. Next, choose the graph which is above the x-axis, which is x is less than 2 or x is greater than 3. Finally, write the required solution. The solution can be in interval notation or in set notation. Example number 2. Solve negative x squared minus 5x minus 4 less than or equals to 0. First step, let negative x squared minus 5x minus 4 equals to 0. Factorize this quadratic equation. We have x equals to negative 1 or x equals to negative 4 as the critical numbers. Next, the function is sketched. Since the coefficient of x squared is negative, this quadratic function has a maximum point and it cuts at negative 1 and negative 4. Step number 3, to solve negative x squared minus 5x minus 4 less than 0, we notice that there are two parts of the graph, above the x-axis and below the x-axis. The graph above the x-axis represents y greater than 0, and the graph below the x-axis represents y less than 0. Choose the graph which is below the x-axis, which is x less than negative 4 or x greater than negative 1. So the solution in interval notation or in set notation. You can try this exercise by using graphical method. We can also solve quadratic inequality by using the number line method. Factorize the equation to get the critical points, which is values of x where the graph cuts the x-axis. For example, 2x squared minus 5x minus 3 is greater than or equals to 0. We factorize to x plus 1, x minus 3 greater than or equal to 0. We consider positive factors, which is x minus 3 is greater than or equal to 0. then x is greater than or equals to 3. When 2x plus 1 is greater than or equals to 0, x is greater than or equals to negative half. Next, we sketch the number line. We take note of negative half and 3. For x greater than or equals to 3 is represented by a solid line, positive, whereas the tail is in dotted line, negative. For x greater than or equals to negative half is represented by a solid line, positive, and then the tail dotted line, negative. The product of the two signs, negative, negative, positive, negative times positive, negative, positive times positive, positive. So the solution is from negative infinity to negative half, inclusive of negative half, union 3, inclusive of 3 to infinity. Example number 2. This example is very similar to example number 1. The only thing is the inequality sign has been reversed. The steps are the same as in example number 1, whereby we consider only positive factors. The number line is still the same for x greater than or equals to 3, and then x greater than or equals to negative half, positive, solid line, negative, dotted line. To get the product, we have positive, negative, positive. You notice that the inequality sign is less than or equals to 0. Therefore, the solution is from negative half to 3, inclusive of negative half and 3. We can also use the table of signs method to solve quadratic inequalities. Number 1, we have to factorize the equation to get the critical numbers. Solve x squared minus 3x less than or equals to 4. Put it in the general form. Let x squared minus 3x minus 4 equals to 0. Factorize and get the critical numbers, which is negative 1 and 4. Put the critical points between the intervals negative 1 and 4, but test by selecting any number from each interval and insert into each factor to get the signs. For the interval x less than negative 1, let's say we choose negative 2. For negative x greater than negative 1 to 4, we choose 0. For x greater than 4, we choose the number 5. By substituting negative 2 into x plus 1, we have a negative number. By substituting 0 plus 1, this is a positive number. By substituting 5 into x plus 1, we have a positive number. Similarly, we substitute negative 2, 0 and 5 into x minus 4. X plus 1 times x minus 4 is the product of the above two signs. Third step will be write the solution set accordingly to the inequality symbol, which is negative. So the solution set is x is greater than or equals to negative 1 and less than or equals to 4. So you can try this exercise for quadratic inequalities.